We are looking at the Ijmb pre-mock past question and answer, and the first question we have here is, what is a projectile motion? Derive the expression for the range of particles projected along an inclined plane theta with an initial velocity u at an angle of theta with the inclined plane. There are so many definitions of projectile motion, but the one I will recommend for students are this one. That the projectile motion is a two-dimensional motion in a curved path vertically upwards with initial velocity u inclined at an angle theta to the horizontal. Let me bring out the definition so that you can get it. Now look at the definition here. So projectile motion is a two-dimensional motion in a curved path vertically upwards with initial velocity u inclined at an angle theta to the horizontal. You can also define the dimension, because the vector, that is the y, as u sine theta. You can attach it after the end of the definition, and ux as u cos theta. Now the reason why I'm encouraging students to go with this definition is because you are doing an advanced level physics, and it is needed that this is the most preferred definition that will match your level. You don't have to go down to defining projectile motion due to the way it was defined in your secondary level. Now let's look at the next question. Derive the range of the particle. Now, from the second equation of motion, I always told students that when they wanted to derive an equation, they should also come up with a diagram like this, a free sketch diagram. And in this free sketch diagram, we'll be having the maximum height here, and we have v here as 0, and we have here as the x, okay, and here theta, and this particle is moving u sine theta. Okay, this is y-axis, this is the x-axis. Okay, now they are asking us to find the range. That is the range, which is the maximum horizontal distance. Now, from this, we will say from the second equation of motion, which says that s is equals to ut plus half at square. Okay, let the s represent the range, and let u be u sine theta. Okay, and let the time t, this is the range, and at this place t is 2u sine theta over g. Then let a, acceleration here, be 0, because at here there was no acceleration. Acceleration was only the velocity changes in this direction vertically, but at the horizontal plane there was no acceleration, so let acceleration be t. Now we can now plug in all our values to this equation. Now from this equation, that s is ut plus half at square, we can now see that where s is arrow, we are now replacing it, and u is u sine theta. Look at the u sine theta here, multiplied by the time of flight at this point, t is 2u sine theta over g, minus, remember, even though you are using the plus sign or a minus sign, there is nothing wrong with it. Let's use an addition sign. Half multiplied by, since there was no acceleration, multiplied by 0 times 2u sine theta over g square. You discover that the whole of this place, anything multiplied by 0 becomes 0. So we'll be left with range is equal to u sine theta multiplied by 2u sine theta over g. Now this place is now 0 because all these things here are multiplying by 0, so they become automatically 0. We'll be left with this. So the range becomes u times u. Okay, we are now taking like terms, multiplied by 2 times sine theta cos theta. Okay, I just collected like terms. For those of you that may not have good foundation, this is what I just did. So u times u is going to give me u square 2 sine theta cos theta over g. But don't forget that 2 sine theta cos theta is equals to sine 2 theta. And this is the meaning of 2 sine theta cos theta. So when we see 2 sine theta cos theta, we can easily replace this as u square sine 2 theta over g. We have just proved the equation for the range of this particular problem. Let's solve for the next question. The next question here says, classify the following as vector or scalar quantities: electric field intensity, electric current, electromotive force, and entropy. Now, it's very simple. When we're looking at electric field intensity, it's simply F is equals to QE. That's force over the charge. So electric field intensity, because of the presence of force, okay, directed because of presence of force, it's a vector quantity. Electric current, it's a scalar quantity. Electromotive force is a scalar quantity. Entropy is also a scalar quantity. Please take note of it, and I'll advise you to go through different of these and different problems concerning scalar and vector quantities, so that you may not have issues in case many other questions may arise that may look different from this. You'll not be having problem of identifying that. Now the next question says, state Kepler's law of planetary motion. Kepler's law of planetary motion, there are 3 laws of that Kepler has proposed, and let's look at the 3 laws. Okay, the law is simply summarized as this. Law 1, the planet describes ellipse about the sun as the focus. Law 2, the line joining the sun and the planet sweep out equal areas in equal time interval. And law 3 can be seen as this. Let's look at law 3. Law 3 is the square of the period t of revolution of the planet are directly proportional to their mean distances r from the sun. And this is the interface of this definition and of this law. These are the 3 laws of Kepler's law of planetary motion. Let's go for the next question. Explain the term parking orbit for satellite and derive an expression for the height of such an orbit. Interestingly, this question is very simple. Now, when we're talking about parking of orbit, let me just give you a simple illustration of parking of orbit. Parking of orbit is when a satellite has the same period, and you should not forget that periods, when talking about periods, we're talking about number of revolution, we're talking about time. It is when a satellite in space has the same period of 24 hours. 24 hours is it's 24 hours that make up a day for the Earth, for the planet Earth. Now, when a satellite has the same period of 24 hours as the Earth, the satellite remains constant on the Earth while the Earth rotates. Now, let me give you a view of this particular explanation. It's a brief explanation, and then we'll look at derive the expression for the height of such an orbit. So when you ask such a question, you can just simply write this down. When a satellite has a period of 24 hours as the Earth, the satellite remains constant on the Earth while the Earth rotates. And on solving the problem, I'll make an illustration and give you a clear sample of what this parking of orbit is all about while solving the height of the parking of the orbit of this satellite. Let's look at the problem, the B part of it. Now, from this, this is the full explanation of this. You can imagine you're given, this is the center of the Earth, this is the Earth, and we have this satellite in this region. Okay, we have this satellite in this region. Okay, and from what we've just explained as parking of orbit, they are having the same period. Now the question is, derive the expression for the height of such an orbit. Now this is the center of the Earth, and this is the radius of the Earth. Okay, this is the radius of the Earth, and this is the distance, which is the height from the satellite from the Earth. So arrow here is equals to arrow plus h, radius of the Earth plus the height. Okay, now if you can recall, we are given that period is equal to 4 pi square arrow square, which is the radius. And this arrow here signifies radius of the orbit of the satellite or distance of the satellite from the center of the Earth. Okay, this is arrow. At this point, this point here, we have here as arrow. The radius of the Earth plus the height. So divided through by g arrow square. Now, we are given arrow as this. If you could remember, g arrow e square is equals to GME. If you now remember, check the relationship. You could check my video on the relationship between small g, acceleration due to gravity and gravitational force, and big G, gravitational constant. You know that g arrow square is equals to GME. Now, we can now replace that t square is equal to 4 pi square, okay, arrow plus h all to power 3 divided through by, instead of using g arrow square, I'll be using GME. So we can now cross multiply, and if we cross multiply, we'll be having that t square GME is equal to 4 pi square arrow plus h raised to power 3. So from here, I can divide through by 4 pi square because we are looking for the h. Remember, we are looking for the h, which is the height. So we can divide through by 4 pi square, and on dividing, it's got a 4 pi will cancel this, and I'll be left with arrow plus h over 3 is equal to t square GME over 4 pi square. Now, this is what we're having. Now, if you can look at this, we can put the cube root on both sides. Putting the cube root on both sides, we'll be having something like this. Arrow plus h over 3 cube root is equals to t square GME over 4 pi square, and we'll be having a cube root. And this cube root will have to cancel this. Okay, and we'll be left with no option but having arrow plus h equal to t square GME over 4 pi square. Now, if you look at this very well, we can rewrite the cube root as 1 over 3. So 1 over 3 is simply the same thing as this. So you should not be confused. And from here, since we are looking for the height, we can now say that h is equals to t square GME 4 pi square, its cube root minus what? We take arrow to the other side, minus arrow. This is the expression of the height of such an orbit. Let's look at the next question. The next question says that, state how the velocity of sound in air depends on temperature, pressure, and humidity of the air. Prove and defend your statement. Hey, if you're watching this video and you have yet to subscribe, please subscribe so that it will give me the enablement to create more of this content. Thank you very much. Let's look at this. State how the velocity of sound in air depends on temperature, pressure, and humidity, and defend yourself. So it simply means you have to convince your teacher that you know what you're saying. That is just simply what the question means. It means if there is anything you have to do, you have to explain to them why is the velocity dependent on temperature. Explain why. Why is the pressure? Why is velocity dependent on pressure? Explain, and humidity. Let's look at the answer. Now, you should know one thing. You can simply put the answer. That of temperature. Sound travel through a medium. So when temperature increases, okay, in a medium, the kinetic energy of the vibration increases. Now, let me give you an illustration. You have this. You have particles here. You have particles here. Okay, and when you ignite you apply a heat here, and the temperature increases. Okay, you put on a Bunsen burner and the temperature increases. You discover that the speed at which this particle moves increased. The speed increased. It moved faster than this there was no temperature rise. So as the temperature rises, you discover that the particles within this range begin to move faster. So because of the vibration, their kinetic energy increases, And since temperature is dependent on a medium, so you can imagine, since sound travels through a medium, you can imagine sound traveling through this medium, that the particle move faster. So it gives rise to fast vibration. Henceforth, it affects the sound of the speed. So as temperature increases, okay, the velocity of sound also increases from this illustration. Now we look at density. We are given that mass is equals to velocity times density. Okay. Now you discover that when you we apply a heat, okay, but I'm not asking you to do this in your exam. You can simply write down just this simple explanation and you get to have your mark. But I'm just giving an explanation so that you can have an understanding. So when a molecule of air is heated, okay, you heat a molecule of air, we observe that the volume of the air increases, okay, while the density decreases. The volume increases. When volume increases, density decreases, okay. And for a fixed mass, because in this relationship, what we're trying to say is that when we say volume increases, it means we are going to be having mass over density. It's got that if for a fixed mass, the volume will decrease because the density will decrease and the volume will increase. So you get it for a fixed mass. So now, hence the increase in temperature give rise now, increase in this temperature give rise to what? Increase and decrease in density. Therefore, the sound of the speed decreases when the density decreases. You get? The sound of the speed increases when the density what decreases, when temperature is being increased. Temperature increased. Now the relationship for this, velocity is directly proportional to the temperature. That is the relationship. It's the square of the temperature. That is just it. For that of temperature, let me give you an illustration of this. Before we get back to density, there is something I omitted here, and I would love you to know. Now you can still back up this your statement that with this that when velocity from this equation, that velocity is directly proportional to the square root of the temperature, which is velocity is equals to the root of t. From this illustration, it means v over root t is equals to, okay, is equals to k. You get? Now it shows that as the volume, as you know, it shows that as the kinetic energy of the vibration increases, it gives rise to fast vibration. Hence, for the sound of the speed, as temperature increases, the velocity of sound also increases. You can also add this relationship as a proof to back up this your statement. As for density, we also use this formula that mass, which is velocity times density, and you drop down this explanation for them and you simply get your mark. Then as for humidity, I discovered that density wasn't given the question, it was pressure. But the one thing you should know, that pressure does not increase the sound, does not increase the sound, the speed of sound. So pressure has no effect on the speed of sound. So that is the answer to that. Pressure has no effect to the heat of sound. But when it comes to humidity, it means humidity simply means more water vapor presence in air. That is sound in air. That was the question. The question was directed to sound in air. It means more water vapor is present in air. That is just the simple meaning of humidity. Just simply means more water vapor in air, in the presence of air. And this statement further means which is more number of molecules in air. More number of molecules in air. That is what it simply means. And this simply implies better and faster propagation. Since sound travel in a medium, and we have more molecules, that is more mediums present to facilitate its traveling, it means there's a better and faster propagation of sound. Hence, increase in humidity means increase in molecules, okay, which is in air, also give rise to increase in the velocity of sound. You just simply use the statement to prove a point that humidity increases the speed of sound in air. Let's look at the next question. The next question says, the length of a string is 2 meters, while the mass is 34 grams. If the string is subjected to a tension of 600 Newton, find the speed of the transverse wave that is set up on the string. Then B part says using sketches states the characteristics of a progressive wave, and derive the progressive wave equation. It's a very simple question. Let's look at solving this problem. 2II. Here we have the question on our blackboard. Now the length of a string is 2 meters. Take down the parameters, and the mass is 34 grams. If the string is subjected to a tension of 600 Newton, that is the tension force. Now tension is a kind of force that is found on strings. You can simply say force found on, you can call it, you normally call it ropes, but these are forces found on strings or rope. You can just use any name you just desire to use. 600 Newton. Find the speed of the transverse wave, the speed, which is the velocity that is set up on the string. Now, there are two formulas behind this. Speed is given as velocity times lambda. And also speed is also given as the square root of the tensional force over nu. This is also given as this. Mu is also given as what? Length over mass, mass over length. Mass over length. Now let's find for mu before we come down to use this formula. These are the two formulas. So we can be using these two. Whichever one fits in, we're going to use it. But for now, since we have tensional force, we have mass, we have length, in this formula will have to go. Let's solve for the mu. Now mu is given as this, but don't forget the mass is given in gram. So we have to convert this from gram to kilogram. So from kilogram, a kilogram is 1,000 grams. So when you're converting from gram to kilogram, you will be dividing. When you're converting from kilogram to gram, you multiply by 1,000. Now, since we are converting from 34 gram to kilogram, it means you'll be dividing the 34 by what? 1,000. We'll be, sorry. Yes, we'll be dividing. We'll be dividing the 34 gram. You just have to place the 34. Since what we have here is 34 gram and we are converting to kilogram, it simply is dividing by 1,000. But if we are having in kilogram, we multiply by 1,000 from what you just said. Since we are having 34, so we'll be dividing 34 by 1,000. That's going to give us the answer in kilogram. Let's bring out our calculator. Now this is a calculator. We have 1,000 gram divided by 34. Now we have 29.4. 29.4 is the conversion. So let's write down 29.4. So on conversion, we got that this is equal to 29.4 kilogram. So mu is equal to 29.4 divided by the length, which is given as 2. Now let's do a division. 29.4 divided by 2. It's going to give us 14.7. 14.7. Mass is given in kilogram. This is given in meter. Length is given in meter. Kilogram per meter. Now we can now use this formula. V, which is equal to the tensional force divided through by what? By mu. And we've gotten mu to be this. So velocity is equal to square root of tensional force is 600 divided through by what? 14.7. So we'll have to do the division before we carry out the square root. Now 600 divided by 14.7. 600 divided by 14.7. We're having 40.8. So V is equal to root of 40.8. So when we carry out the square root of 40.8, we'll be having that the velocity is equal to 6.3 meter per second. Let's have to solve for this problem. Now look at the next question. Using sketches, state the characteristics of a progressive wave, and derive the progressive wave equation. Now let me clear up this space and let's do out some explanation here. Now what's a progressive wave? This is a progressive wave. This is a progressive wave. Okay, here we know here is the crest. Here is known as the trough. Here is the amplitude, x vertical height, and also the distance from here to here is lambda. Distance from here to here is lambda. And if you notice this, if you pick the first move cycle like this, and you pick the second cycle like this, now if you place them together, you discover that you'll be having a complete cycle. So this like this has made a complete cycle. Now, this is the direction. The progressive waves, it's move in the direction of the vertical, and its movement, it's towards the horizontal direction. It's I can simply explain a progressive wave. Notice that the oscillation is perpendicular to the wave motion, and if you notice, this is the perpendicular, it's perpendicular to the wave motion, and it's moving towards the s direction with time t. Now, there's what we call phase angle, and the phase angle is given as 2 pi x over lambda. I will explain. Now, you remember that 2 pi is 2 multiplied by 180, which is 360. Now, this particular wavelength has made 360 a complete cycle. I give you an illustration here earlier. It has made a complete cycle, which is 360. And this oscillation is directed towards the x-axis and is moving over what's a wavelength, which is called lambda. And the y direction is given as a sine wt. Now, this is the y. A, the amplitude towards the vertical axis, and whenever it is vertical, we use sine. And W, you should not forget that W is an angular speed, which is given as theta over time. Okay, and for this, it's simplified that y is given as a sine wt. It's just a denotation, it's just a proof, but there's no time to prove that. Now, from this, we can now denote that y is equals to a sine wt plus or minus the phase angle. Plus or minus the phase angle. If it's moving towards the right, it's a negative sign. If it is moving towards this direction, if it's moving towards this direction, it's a negative sign. If the wave is moving towards this direction, it becomes a positive sign. So we can now conclude that y is equals to, from this our diagram, y is equals to a sine wt minus phase angle, because it's moving towards the right side. So y becomes a sine wt, and the phase angle is given as what? 2 pi x over lambda. We've proven an equation for a progressive wave. We've just proven an equation for a progressive wave. Now, what is the characteristic of a progressive wave? They say using sketches, state the characteristic of a progressive wave and derive the progressive wave equation. This is the progressive wave equation we've derived. We can still use equation to get other equations, but I'm not really going into that, because what I'm doing right now, I'm only answering the past questions. Now, if you have not subscribed, you've not done well, please subscribe. It's very important, and drop your comment. To drop your comment, and I not only that, share the video to other Ijmb students. Now let's look at the characteristics of a progressive wave using sketches. Let me clear up this space. Now, this is a progressive wave. So if you notice, we have 2 pi times 2. Here to here is complete, here to here is complete for a progressive wave. Now, we can also draw this again. So what I'm simply asking you to do is, look at this. We are going to reduce this, and on reducing this, we are going to add it to this. So adding to this, we are going to be having something like this. Take note, we have gotten this one complete. Okay, we've gotten this one complete. ensure that you notice this one, we've gotten it here. And remember, we have reduced this and place it behind. So we'll come down again. We want to take this up. Okay, on taking this off, it means this one, if we take this off, it means this one has to come and join here. And on joining here, we're going to be having a complete cycle like this. Take note, this is complete. Take note, this has been completed. And take note, this has been completed. But remember, we've removed this and we added it here. And the last one is going to look like this. We are taking off half of here. And taking off half of here, we're going to be having something like this. Okay, we are adding it here. We've gotten this side completed. We've taken half from here, so we had to extend it here. So this is completed. We go up again. This is completed. We come down. This is completed. You should not forget. And remember that this one here, we've already taken half. So we'll leave it like this. So simply, this is 1 over 4. This is 2 over 4. 2 over 4. This is 3 over 4. And this is 4 over 4. And that gives you the answer to this particular question. Let's look at the next question. The next question says, a plane progressive wave is represented by y is equals to 50 sine into bracket 100 pi t plus pi x over 5, where y is vertical displacement in centimeter. Okay, t is the seconds, s is distance in meters. Evaluate the amplitude. Take note, evaluate the amplitude, the wavelength. We are finding amplitude, we are finding wavelength, and velocity of propagation of the wave. Let's get to our blackboard. So here is the question. So let me write down the question. Y is equals to 50 sine 100 pi xt plus pi x over 5. Now they have defined the terms. I say evaluate the amplitude. Okay, the wavelength, velocity of propagation. Those are the 3 things we have to find here. Now, you should not be confused. Don't get confused. In this kind of question, we do what we call compare. We compare the equation, which is this, with another equation. Now, there are several equations. There are about 3 of the equation. But for the case of this video, I'll be bringing only one of the equation that matches this particular equation. And if you care to know other equations, in case the question may be framed differently, then drop that at the comment section and I'll do that. And not only drop that at the comment section, I also want you to subscribe. If you have not subscribed, you have not done well. If you have not liked the video, if you have not shared the video, you are not doing well. Students are always confused when it comes to solving this question. There is nothing to be confused here. Now look at the equation we are going to comparing this with this. We're having that a sine bracket 2 pi ft, okay, minus 2 pi x over lambda. This is a progressive wave equation that could be derived from the other progressive wave equation that we've just looked at. So it's from that progressive wave equation we looked at, we can use that to get this equation. There are 3 other equations we can bring out from that progressive equation. But if you want me to make a video on that, drop a comment and say, sir, make a video on that so that we can get full understanding. And also subscribe and share. Now, this is how we do it. Look at y, look at y. Look at 50 sine, look at a sine. We cannot start now. A sine is equals to 50 sine. So what we've just done now, we've compared it. 50 sine is equals to a sine. And on doing that, we cannot divide through by sine because we are looking for amplitude. Therefore, sine will cancel out sine, sine will cancel out sine, and A becomes 50. That is the amplitude for A. We have got that 50 meters. Remember, our amplitude is in meters. Now, the next question is, what is the wavelength? Well, if we look at the wavelength, let's look at the frequency. Now, look at frequency. We have that 2 pi ft, okay, is equal to, look at, we compare it with this 100 pi xt. Now look at this. Since we're looking for frequency, what can easily divide? We can easily divide through by what? Pi t. Or we can say let's divide through by 2 pi t. 2 pi t. You discover that we want to look for frequency. This will cancel this. This will cancel this. When it comes to this side, t will cancel t. Okay? And pi here will cancel pi. And this will cancel this, and we'll be having 50x. So we keep this for now. Let's look at lambda. Let's look at lambda. How we arrive at lambda first. Now, look at lambda. We have pi x over 5. Let's hold on for this. Is equal to, look at what we have it here with. Okay, we have, sorry, this equation, it's supposed to be a negative sign, not even a positive. It's supposed to be a negative sign, not even a positive. So we'll be having negative, okay, pi x over 5. And we're having, in most cases, they are always the same. And we're having negative 2 pi x over lambda. What do? The negative sign will cancel the negative sign. So how do we solve for pi? We just do a cross multiplication. We'll be having pi, okay, x cross multiply. This will multiply this, multiply by lambda is equals to 5 times 2 pi x. Since we are looking for lambda, we'll be dividing through by pi x, okay? And pi x will cancel out pi x. It will be left with lambda. Pi x will cancel out pi x. It will be left with what? 2 times 5. So lambda becomes 5 times 2, which is equals to 10 meter. This is some comparison. Now, we can now say that we were left with what? F is equals to what? 50 what? X. From here, F here is equals to 50x. So F is equals to, we are not solving for x. We are not looking for frequency. The question did not ask us to look for frequency. So we have to avoid this. But in case we ask to look for frequency, there's possibility of solving. That's just want to tell you how we can do the comparison. But the question is asking us to look for what? The amplitude, which we've gotten. They're asking us to look for the wavelength, which we've just gotten as 10 meter. Now the velocity. Remember that velocity is equals to frequency times lambda. Then now is importantly that we have to solve for frequency. Then how do we solve for frequency? Now, we solve for frequency by saying that, hold on. So I just verified the question. Let's look at our question paper. There was no x in 100 pi xt. So this question was actually wrong. So frequency here becomes 50 hertz because there was actually no x here in this equation. Let's verify on our question paper. So if you look at our question paper, there was no x. So the equation we took to the blackboard was incorrect. So for sake of clarity, I had to find frequency back so that it would be more easier. So just follow me through. So we've gotten amplitude as 50. Now, frequency, we compare it, we say 2 pi ft is equal to 100 pi t. So we'll be dividing through by this, and dividing through, we want the frequencies to be alone. Divide everything that is close to the frequency and leave only the frequency. We divide through by both sides. 2 pi had to cancel 2 pi, t had to cancel this. On comparing this equation, then t will cancel t, pi will cancel t, and it's going to 2 divided by 100 divided by 2 is going to give us 50. So the frequency now is giving us what? 50. And if you can recall, we've already found lambda to be what? Lambda is already giving us as what? 10 meter. Lambda is giving us 10 meter. So from this equation, they say find the velocity of propagation, v is equals to f lambda. We can answer that velocity is equals to the frequency, which is 50 hertz. Please don't forget to put the SI unit. 50 multiplied by what? 50 multiplied by what? 10. and let's do that. 50 multiplied by 10 is going to give us 50 multiplied by 10, which is going to give us 500. 500. So the velocity becomes 500 meter per second. This is how to solve for this problem. If you like this video, please, I would love you to share the video and also like, share, and also subscribe and drop a comment. And if you have any problem with your Ijmb past question, you can just comment on it and drop a comment on the comment section and say, sir, we want you to solve problem for 2022, 2019, any of the year, any of the areas, paper 1, paper 2. If you have any challenge, just drop a comment. But please subscribe, very important. Thank you and God bless you.